Today we're going to talk about kidney function test. So before we start, let's go through a quick revision of the kidneys and the function of kidneys. So first of all is a cross-sectional picture of the abdominal. The lower part is the back, the upper part is the front, and hopefully we can all find where the kidney is. I have a pair of kidney, bean-shaped organs located at the back near the spinal cord just under the rib cage. Within the kidney, there are two regions. There's the cortex, its outer parts, and medulla is the inner parts. Majority of the function of kidney is performed by the nephron, which in healthy individual, you should be born with about 1 million nephrons at birth from each kidney. So you total about 2 million nephrons. However, this number might be different, depends on your nutritional status of your mother during the pregnancy. Next slide is two pictures of location of the nephrons. One's from front, and the next picture is a cross-sectional of the kidney. And you can see the lighter brown area, the outer one is the cortex. The darker brown color is medulla. And the next picture is further illustrates the complete components within the nephrons. So you've got the Bowman's capsule, followed by proximal tubules, go to loops of Hines, and distal tubules collecting ducts. In the big picture there, you can see there's two nephrons, one on the left, one on the right. This picture is aimed to illustrate to you that not every nephrons are the same. Nephrons have differences, and you can see some of them have longer tubules, or certain parts of the tubules are longer than the others. Alright, so these two diagrams, these two pictures is actually a microscopic picture of the kidney, and more specifically is the cortex components. You see in the right hand side the picture there, they have three round shaped components that put into highlights in the square. Those are actually the glomeruli, and the rest of them, the outside you see the white bits, there's the Bowman's capsules, or there's a space between capillary and the Bowman's capsules. The rest of the components is where the tubules are. The picture on the right hand side is actually the magnifying components of the glomeruli, and you see all those holes in there. That's where the blood vessels are. And you see it's all packed with blood vessels, and this is where blood filtration is actually occurring. So let's recap. There's 5 basic parts of the nephrons. You've got the glomeruli, it's mostly filled with the capillary turf, surrounded by expanded end of the renal tubules, which is the Bowman's capsules. And then you've got the proximal convolution tubules, is right next to it. It's located in the cortex. And then you've got the loops of Hines, comprising of descending and ascending limbs, which is located within the medullas. And then next part it goes to distal convolution tubules. This one going back into the cortex area, and they all join from multiple nephrons. It join together into the collecting ducts, and it go from there and into all join together, go to the ureters and ureters, and then go into the bladders. So this is details diagrams of one nephrons, and you can see where's the glomeruli and glomeruli, turf capillaries, and Bowman's capsule. And you see when the blood vessel come in first into glomeruli, gut filters, and then you see the blood vessels go back out and actually twinkle around the whole proximal loops of Hines and distal tubules, and that's where how the nutrients and fluids got reabsorbed and can go back into circulations, and then it join back into renal veins and capillary blood, and then go back to circulations. So let's do a quick overview of the physiology of human kidney. At birth, you got the kidney start working unless you born prematurely. So the kidney starts to work within halfway into the third trimester. So you actually start producing urine before you actually born. Right, at this stage, we already have the full components of the kidneys. So the number of nephrons already set around these times. No new nephron will be created after birth. Okay, so for most healthy individuals, we were born with about 1 million nephrons within each kidneys, and recent study have shown that some people are actually born with less, especially uh, in indigenous and Torres Strait Islanders. It might be there's a couple theory behind that. One is that the nutrition of the mother during pregnancy are determining factors. The other one we suspect is probably genetic factors. But this is the area of research, and we still don't have the full answer about. Anyway, so your kidneys will be fully functional for the body within 6 to 12 months after birth. So at birth, the amounts of urine's waste capacity of urine productions and waste excretion and fluids and electrolytes management is actually not at full capacity yet, and you reach full capacity after 6 to 12 months of age. Depends on each individual. Depends on each individual. Obviously, some develop a bit faster than the other. So this is where the full functions of glomerular filtration rate is measured. It doesn't necessarily represent the other parts of function, and we're going to talk about them a bit later. Right, this is when the kidney function matching the body size, and after that, the kidney continue to develop, the body continue to grow, but kidney develop much faster than body. So after 6 to 12 months of age, we start accumulating functional reserves. So we actually have more kidneys mature, nephron mature than what the body require. And these would continue until the person's reach puberty, and after puberty around 20 years of age is where you got to maximum capacity, but the growth probably just stop around there. So from birth to fully function or fully mature kidneys, it increase in size quite dramatically, about 10 times or even more. And if there's a significant damage to the kidneys before it fully matures, then remaining kidneys can actually compensate by growing more extensively. So in the previous diagrams, we see the one with two separate nephrons. Then you see some nephrons bigger, some nephrons smaller. Okay, if you lose one kidney before you fully matures, the other kidney will observe they're actually growing much bigger into size, and you look at the microscopic biopsy sample, you see the nephrons actually more of them will be measured into big size, larger size. So the body's way to compensate for early loss of the nephron. One is glomerular filtration, filter incoming bloods. The bloods come from the aortas, go into renal arteries, and then go into the individual glomeruli. So what factor determines how much or what's being filtered is three primary components. One is the high pressures as well as some pressure gradients within the glomeruli capillaries. That's since there's pressure gradients, it causes fluids component in the blood to filter through the capillary. Second is that within the glomeruli basement membrane is actually a lot less leaky, so it's semi-permeable, allow a lot more things to filter through compared to a normal blood vessels. And third one is the negative charge of the basal membranes, so that regulates against negative charged particle to be filtered. So negative things like proteins are highly negative charged, so will be more likely to retain within the blood vessel instead of getting filters. In healthy kidneys, we probably filter about 20% of fluids that flow through the glomeruli. That if you consider that normal, the blood of normal individuals, that half of them probably blood cells, the other half is fluids. So that represents about only 10% of the blood in volumes get filtered once it passes through glomeruli capillary. Right. Given that the blood flow to the kidneys is about 1/4 of cardiac output, so about 1 to 1.5 liter per minute, that means if you do calculations, about 700 mils per minute of plasma flow to the kidney, and the filtration rate will be 120 to 130 mils per minute. Right? That's equal to over a day a healthy individual will filter blood, about 170 liter of blood. That would means the blood, each unit of blood actually go through filtrations 30 to 60 times in one day. So that's how efficient the kidney function and kidney filtration can be. Right, next one, we look at the tubular functions. After glomeruli, you look at tubular. So there's 4 components in the tubular. So you've got the proximal convolution tubules, where majority of the reabsorptions actually occur, return very valuable nutrients, trace elements, essential nutrients back into blood by designs, but sometimes some toxic components, because it resemble what the essential nutrient will be, can also get reabsorbed. Tubular secretion also happen at this area. And then second part is loops of Hines. Loops of Hines is where most water, sodiums, and chlorides get reabsorbed, which ultimately contribute to the outcomes of osmolarity and water control. The third bit is distal convolution tubules. Sometimes can be pretty long within the distal convolution tubule, depends on its nephrons, and this is where the final adjustments of pH, electrolyte fluids can happen, and this is where the hormone regulating hormones actually act on. So the ADH, the aldosterone, most of the effects is occur within the distal convolution tubules, and collecting that final sites of concentrating or diluting the urine depends on the hydration status of the body, and then there's a pre-urine that will collect together and transfer into bladder. So these are the 2 diagrams to illustrate to you what we just described, the physiology of the kidneys from the blood capillary to the distal tubules, but this is in summarized illustrated form. Right, so now we talk about the function of the kidney to start. So for the first function, the most important function that we know of and we monitor the kidney for the removal of waste products, homeostasis for electrolytes, waters, and acid-base balance that we've gone through in previous 4 lectures, and also we excrete any xenobiotics or metabolite of xenobiotics. Xenobiotic basically means that any chemical compounds that is not produced within the body. So it's like drugs, chemicals, whatever you consume, whatever you contact, manage to get into bodies. So the body naturally wants to get rid of these components. Right, so the mechanisms of how the body remove the waste and maintain homeostasis, the first is through filtration. Filtrations occur at the glomeruli through the turf of capillary. Fluid that pass through the membranes is called filtrates, and the filtrates collecting in the starts of the nephrons is called the Bowman's capsules. So next part, after it got filtered, it got to Bowman's capsule and flow through the tubule. So start with tubular reabsorptions. Tubular reabsorption is reabsorb all the organic nutrients that our body needs, so things like glucose, amino acids, vitamins, things like that. All of these reabsorption of essential nutrients occur at the proximal convolution tubules, and normally all these nutrients that the body needs would be reabsorbed. Okay, so the question asked here is, when is that not the case? Some of the because this reabsorption is going against concentration gradients, so it actually have to go through active transport system. So once you have too much that oversaturate the active transport system, then you are unable to reabsorb everything, and then when you start finding things in the urine. There's, for example, in diabetes patients, the reabsorption capacity of glucose is equivalent to around 10 to 11 millimoles per liters of blood glucose level. So if your glucose level is higher than that, the amount that CAP filters would not be fully absorbed through the tubular reabsorption system, and some, once it passes the proximal conversion tubule, there's no transport system to reabsorb the glucose anymore, so they will end up in the urine. Right, the second one is iron. So remember we talked about iron reabsorptions within, or ions in electrolyte reabsorption within some things. To remind you, there's a isosmotic amounts of water get absorbed with solutes and nutrients, and if the body needs further waters without the electrolytes, sodiums, they have to go through water channels, which is happen further down at distant convolution tubules. That's where the effects of ADH and effect of aldosterons will get done, not at the proximal convolution tubules. The water and sodium reabsorptions also, majority of them actually occur within the loops of signs. So this allows the urine get concentrated, especially if we need to preserve the fluid. The other mechanism is tubular secretion. This one is a bit less able to predict. We usually the body have a way to excrete unwanted metabolites or unwanted xenobiotics, and some substance can be cleared from plasma much faster than the filtration rate, and obviously some usually relate to something the body need to adjust very quickly or need to get rid of very quickly. So things like if you have excess amount of hydrogen ions, so potassium, nitrogens, they usually can get excreted more than just filtrations. Creatinines, I put the star up there because in healthy individuals, the active excretion of creatinine is actually very, very low. It's negligible. It's only about 1% of, or less than 1% of creatinines excreted into urines is through tubular secretion. However, as your kidney filtration functions start to diminish, the excretion function doesn't. Okay, therefore, more and more can be up to 10%, 5 to 10% of the creatinine excreted in end-stage kidney failure patients are through tubular secretion. That makes the estimation of glomerular filtration rate a little bit difficult when we'll talk about that later. A lot of chemicals, drugs, metabolites can be excreted through active transport, tubular secretion as well. One of the examples, penicillin. So penicillin actually excreted like twice as fast as the your glomerular filtration rates are able to perform. There's also tubular secretions, also very important in maintaining pH balance. Remember we talked about pH acid-base disturbance, how the kidney able to excrete hydrogen by itself, or hydrogens or bicarbonate rates or bicarbonate. Also, electrolyte regulation, for example, potassium can be actively secreted in a smaller amount. Right, so next mechanism is the removal of urine. So urine would then contain all the unwanted filtrates, things that have been excreted, or things that are unable to be reabsorbed or fully reabsorbed. So which have characteristics of colors and transparencies. So that depends on whatever concentration. So the more dehydrated you are, the more concentrated urine will be, the darker color it will be. So if you watch the TV programs like uh, embarrassing body series, they have a few episodes actually go to check how people aware of the dehydrations, and one easier way to collect urine sample and actually match the color with it. Right, within the urine they also have unique odor, so that is mostly contributed by ammonia. Ammonia can be from the breakdowns of amino acids by the body itself or by the bacteria when they break down nitrogen-based products. Right. The specific gravities also determined by the concentrations or osmolarity of the urine. So specific gravities usually once means the same as in water. Therefore, in urine, it always more than once and depends on how much substrate solutes within the urine. The more they are, the higher the specific gravity, obviously. So once the urine go through the ureter, it ends into the bladders. Once it into ureter, it no longer body can no longer alter the components in there. So we cannot reabsorb or we cannot excrete any components in there. However, within the bladder, the urine will continue to change because there's a small amount of bacteria will be in the bladders, so it can start breaking down some of components and change odor, change colors, and change the pH. Right, so that's the filtrations parts of the kidney function. So next part of the kidney functions are the endocrine functions. So remember when we talk about full back examination, we mentioned something about prostate glandins. Oh, hang on, this is the next part. Let's come back. Uh, Remember we talked about water and electrolyte regulations. There's the renin, angiotensin, aldosterone systems. So renin's actually secreted from the kidney. So it actually starts from kidney and come back all the way to blood vessel and come back eventually aldosterone's effect on the distal tubules. It also produces prostaglandins. In basically is increase the blood flow through the local uh, networks to the local nephrons, or increase blood flow through the urines if the person's significant blood flow been decreased, like patient with low blood pressure, for example, those kind of things, or acute blood loss. You see that the body actually the kidney actually try to increase the own blood flow by producing prostaglandin.